So, first things first. What exactly is a diode? A diode is a small semiconductor device that acts like a one-way valve for electric current. It lets current flow easily in one direction, but pretty much blocks it from going the other way. Think of it as a check valve in plumbing. Water, or in this case, current, can go one way but not back. Now, how does it actually work? Most diodes are built around something called a p-n junction. You've got two sides, the p side, positive, doped with materials that create holes or positive charge carriers. The n side, negative, doped with extra electrons as negative charge carriers. When these two meet, they form a special boundary layer called the depletion region. When we apply voltage, two main scenarios happen. First, forward bias. We connect the positive terminal of our power source to the P side and the negative to the N side. This pushes holes from the P side and electrons from the N side toward each other. They recombine, the depletion region shrinks, and current flows freely once we reach a small threshold voltage. Second, reverse bias. Flip the connections, positive to N side, negative to P side. Now the depletion region gets wider, almost no current flows, just a tiny leakage, and the diode blocks the flow. Here's a quick visual to help picture that forward versus reverse bias setup. And here's the standard circuit symbol for a diode. The arrow shows the direction conventional current is allowed to flow, from positive to negative, anode to cathode. A few key numbers every diode has. Forward voltage drop, Cicado VF, the voltage you need to overcome before it really starts conducting. For everyday silicon diodes, that's about 0.7 volts. Germanium ones are lower, around 0.3 volts. Reverse breakdown voltage, VBR. How much reverse voltage it can take before it breaks down and lets current through? Usually not good, unless it's a special type. Maximum forward current, Imax. Don't push more current than this, or the diode overheats. Now, not all diodes are the same. Let's look at the most common types you'll run into. First up, the classic rectifier diode, like the super common one N4007. These are the workhorses for turning AC into DC. Then we have LEDs, light-emitting diodes. They glow when current flows forward. Red ones drop about 2 volts, blue or white closer to 3.3 volts. Always use a resistor with them. Zener diodes are special. They're designed to break down in reverse at a precise voltage and keep regulating it. Great for making stable voltages. And photodiodes. These work backward. Shine light on them in reverse bias and they generate a tiny current. Perfect for light sensors. Here are some real-world photos of different diodes side by side so you can see what they actually look like. Okay, let's see diodes in action with a few practical examples. One of the biggest jobs diodes do is rectification, converting AC to DC. The simplest version is a half-wave rectifier. You put one diode in series with the load. On the positive half of the AC wave, the diode conducts and you get output. On the negative half, it blocks, so you end up with pulsing DC instead of smooth AC. Here's what that circuit and waveform look like. Next, voltage regulation with a Zener diode. You connect a resistor in series, then the Zener in reverse across your load. As long as the input voltage is high enough, the Zener holds a steady voltage, say 5.1 volts, across the load, even if the input wiggles around us a bit. Super useful in power supplies. Check out this typical setup. Diode as a voltage regulator. And finally, a super simple one almost everyone starts with. Lighting an LED safely. Just put a current limiting resistor in series with the LED and your power source, like 5 volts. For a typical LED, a 330 ohm resistor works nicely with 5 volts. Without the resistor, poof, the LED dies quickly. Here are a couple of easy breadboard examples. And that's diodes in a nutshell. They're everywhere. In phone chargers, LED lights, solar panels, radios, you name it. Super simple, but incredibly powerful.